Right now, we are super happy to welcome Ed Felten. He's the Chief Research Scientist on Offchain Labs and one of the first builders of Arbitrum. His previous position include Professor of Computer Science and Public Affairs at Princeton University and Deputy United States CTO at the White House. And he's a member of the U.S. National Academy of Engineers, American Academy of Arts and Science, and is a fellow of the ACM. And I don't know if you remember, but Arbitrum started, like the development of Arbitrum started in 2014. And actually, because of Ed, is like he's the starter of Arbitrum. So yeah, we're super excited to have this conversation with him. He's going to share more about what's coming for Arbitrum, what they are building in Offchain Labs, and yeah, let's see what he's going to say. Let's give him a big round of applause. Woo, let's go, Ed.
Everybody, hello, Arbitrum. So I'm here to talk about the future of Arbitrum, but importantly, the title of my talk is Predicting the Future of Arbitrum. Why predicting? Well, a core value of the Arbitrum community is your chain, your rules, right? And so that means that for the DAO-governed chain, the DAO makes the rules. For Orbit chains, the chain owner makes the rules. And so that means that I am not here to tell you what will happen or even what should happen on your chain. I'm here to tell you what can happen, but what does happen on your chain is up to you. Your chain, your rules. All right, of course, any talk about the timeline of Arbitrum in Layer 2, we really have to kind of start with Vitalik's roll-up-centric Ethereum roadmap. Goes back to 2020. This was the idea that Ethereum was going to go, if not all in, at least mostly in, on roll-ups in Layer 2 as an approach to scaling. Well, and we can ask, well, how is that? That's how it started. How is it going? Layer 2 and 3, we can measure how much activity measured in multiples of Ethereum we're seeing on Layer 2 plus Layer 3 in the Ethereum stack. So on a typical day, we see that Layer 2 and 3 are about 30x the TPS of Ethereum, about 80x the gas usage, about 40x the call data, out of more than 50 L2 and L3 chains. And that means a couple things. First of all, that Layer 1 is now maybe around 3% of the activity in the Ethereum stack. So Ethereum is a Layer 2 and 3 phenomenon these days, much more, I think, than many people realize. Also, at least with this audience, I need to emphasize that the majority of this is on the Arbitrum stack. Indeed, more than half of this activity is in Layer 3 orbit chains alone. Layer 3 is the biggest. Layer 2 is a close second. Layer 1 now far behind in activity. Layer 1 is critical as the foundation of the security and operation of Layers 2 and 3. But the action is up in Layer 2 and 3, and the action is in the Arbitrum stack. OK, I want to take a minute and kind of review or level set on how the current Arbitrum stack works. There are some misconceptions out there, but I think it makes sense to think about or talk about a little bit, how does this all work before we talk about what's coming next, or what can come next. The design of Arbitrum really kind of breaks down, the Arbitrum stack, it really kind of breaks down into these 4 components that operate independently but in a co-designed way. First, you have sequencing. User transactions come in, they go to the sequencer, and the sequencer's job, and its only job, is to take those transactions, record the fact that they arrived and in what order, and then to publish that ordered sequence of transactions. The sequencer does not decide the outcome of transactions. It does not set fees or collect fees or ever hold fees. There is no such thing as sequencer fees. There's only chain fees. The sequencer's one and only job to put transactions into order. Once we have an ordered set of transactions, then we move on to execution. Execution actually runs those transactions and determines what is the result. Compute the blocks that are built from those transactions. The beauty of this architecture is that everyone can run the execution part of the technology themselves. And indeed, if you're running an Arbitrum node, you are running the execution layer. This is a deterministic rule which, given the output of the sequencer, produces the blocks of the Arbitrum chain. And if you subscribe to the sequencer's feed, you know what the chain is doing. The next piece of this is data management. Data management takes that sequence of transactions produced by the sequencer and records it on Ethereum, and does that in the most efficient way that it can. So its job is to record the transactions. It puts them in batches, it compresses them all for efficiency. It even times when to write them onto Ethereum in order to get the best price in terms of Ethereum gas price. The result of that is that the sequence of transactions is now canonically recorded and final on Ethereum, and now your transactions results are final. And then finally, you have the proving phase, which proves to Ethereum. Everyone else already knows which transactions are, what the correct blocks are, but this proves to Ethereum and allows Ethereum to checkpoint the correct result. And it proves to Ethereum that if you execute the transactions that were recorded onto Ethereum, according to the deterministic execution rule, that a particular result will come out. So that's what we have today. That's how Ethereum, or how Arbitrum currently works on L2 or L3. Let's talk now about where we can go from here. And I have a bunch of things to talk about that are in the research pipeline. Some of them you've heard about. Some of them I hope you're already excited about. Some of them we've never talked about publicly before right now. All right, let's start. Here's a set of things that are coming to Arbitrum soon or on the horizon. All these things will become available. We're talking about stylus, bold, node performance upgrades, time boost, decentralized sequencing, as well as the use of ZK proving as part of the Arbitrum proving technology. First, stylus. Now, if you're not stylus-pilled already, I guess you must have just come in. Stylus is, to me, one of the most exciting things that has ever happened in Web3. It's really transformational because it takes us from a world where you either use a Solidity and EVM chain or you use a Rust, a C, C++ chain, now to a world where you have the best of both all together and fully composable. You can take some Rust code, like on the upper right here, just decorate it with this directive to the compiler. Boom! Now this can run on an Arbitrum chain, fully interoperable, fully composable with EVM code. There's a beautiful SDK that allows developers to use this. Really easy, really important. Lets you write smart contracts in any language and much more performant. And I can't say this enough, fully composable. All right, let me talk as well about Bold. Bold is the third generation Arbitrum proving protocol. It is still the only fully secure, fully decentralized fraud-proof protocol that exists. It's resilient against against worst-case Ethereum censorship. No other protocol can say that. It doesn't rely fundamentally for its security on a Security Council veto. No other protocol can say that. This is the only fully secure, fully decentralized fraud-proof protocol that has ever been built. And this, again, is available for the DAO to deploy. The guarantee that this gives is the strongest security guarantee you could possibly hope for. Any one user with an ordinary laptop can enforce safety and progress of the chain at the protocol level. No other protocol can guarantee this. All right, those are the things that are already there, before the DAO, already fully implemented and ready to go. What's on the horizon? Let me talk about a few things. First, an important goal is to push performance. That is to get more capacity, more throughput out of the same node hardware by being smarter about how we do our engineering and how we manage resources. So that starts with efficient execution. Stylus gives you for computational workloads, depending on the workload, 20 to 100x improvement in how much computation you can do with the same gas. That's huge. Second, we have work that is getting underway to do an integration of the Arbitrum node with Reth, which is a new and highly performant Ethereum node. And that will allow the performance capabilities of Reth and its more efficient resource usage to be available to Arbitrum nodes. We have work on more efficient pricing and more efficient management of resource limits. It's the fact today that on any Ethereum stack chain, and indeed any blockchain I know of, that a chain can be operating at the gas limit, and yet there are unused resources on every user node. We want to try to fix that. We want to make it so that if there is an available resource and some on the ordinary user node, and some application wants to use it, that's possible. So that means moving beyond the single gas limit. And then, in addition to push performance, everything I've talked about so far is vertical scaling, getting more performance out of one chain. We're also working on how to get more performance by scaling horizontally. That is, by having cross-chain interoperability that is fast and trustless. So let's talk about, again, more efficient execution. I talked about Stylus. I talked about Reth-based Arbitrum nodes, which can attack the storage access bottleneck. And to more efficiently use resources, we have a technology called constraint-based pricing. This basically allows smart contracts to use the full resources that are available by nodes. You don't have an artificial limit on gas limit. To give just a very quick summary of why this is an improvement, the current gas limit on any chain is set based on a sort of worst-case analysis. What is the worst thing that could happen? And set a gas limit low enough that that worst thing is not going to break a node. What constraint-based pricing lets you do is look at what's actually happening and only throttle down the performance, only raise the cost when some resource is actually being used to its limit. Not based on some hypothetical worst case, but what's actually happening. So that lets you have a lot more performance out of the same node because you're actually using that node fully. And this also gives you better resilience against extreme traffic patterns, where you have a huge sudden swing in what users are using the chain for. Those of you who remember the inscriptions events will know what I'm talking about here. I'm going to talk a bit about sequencer improvements. This is really important. So the Arbitrum sequencer already has a unique value proposition, already gives you all of these green checks. The fastest response time for user transactions of any Ethereum stacked chain, fast arbitrage time, faster than any other chain I know about, and that makes DeFi markets most efficient. One of the big reasons why Arbitrum is the home of L2 DeFi. The chain almost never reorgs. Arbitrum 1 and Nova have processed over 1 billion transactions with one reorg. That also is pretty unique among any performant chains. It protects users against front-running and sandwiching attacks, and the sequencing method is simple, fair, and easy to understand. But there are two more things that we would still want to do and that we hear from the DAO that the DAO wants to do. And that is to be able to internalize MEV value for the chain and to make the sequencing mechanism fully decentralized. So let's talk about capturing MEV revenue. There's a proposal now called Time Boost. And the idea here is pretty simple, that in the sequencer, which currently does first-come, first-served processing, we create an express lane. And the sequencer uses first-come, first-served sequencing all the time, but transactions that are not in the express lane experience a small additional delay, about 200 milliseconds. Every minute, you auction off to the high bidder the right to control who can use that express lane and for the next minute. That revenue goes to the DAO, your chain, your rules, your revenue. Or for an Orbit chain, it goes to the chain owner or where the chain owner wants it to go. This is, I think, a clever way of capturing the MEV revenue. The parties who are currently competing, racing to get their transactions in first, to do back running or to capture arbitrage, they now have incentive to bid against each other because what you're selling here is the right to win any race to capture arbitrage or back running during that 1 minute. And so we think parties will be willing to pay essentially the value of the arbitrage or backrunning opportunities during that minute to the chain, allowing the chain to capture that value. And importantly, allowing this to happen without sacrificing any of those other green checks on the previous chart. Which brings us here, leaving only decentralization. And this, by the way, is the last step in the Arbitrum decentralization roadmap, decentralizing the sequencer. The only thing that is not yet decentralized once Bold comes in. So let's talk about that a little bit. We have a joint project between Offchain Labs and Espresso Systems to build a decentralized sequencing system. I can tell you today that the design of that protocol is complete and that the engineering effort is starting to build it. What this does is essentially takes the centralized function of the sequencer and divides it across a committee of sequencer nodes. Imagine, say, 20 sequencer nodes chosen by the DAO or by the owner of an Arbitrum chain, of an Orbit chain, based on trust and reputation in the community. And provided that a majority of those nodes, suitable majority of those nodes is honest, you get all the advantages of the current sequencer, but in a decentralized way. So if there are 20 nodes, you can tolerate up to 6 of them being dishonest, and you still get all of the good properties, speed, fairness, and no front running. This, again, is unique, I think, in among the designs that are in the research community among any chain. I want to close out by talking a bit about the role of ZK proving. This is a question I often get when I talk to sort of general blockchain communities, and it is, well, isn't ZK proving really the thing? Isn't ZK really the future? And my answer to that is no. I don't think ZK is the future. I think the future is actually something more efficient than ZK, that is a hybrid protocol. So how are we going to get there? Well, how are we going to get to this future of where ZK proving plays a role in Arbitrum and provides universal fast withdrawals? Well, it will likely be possible soon to ZK prove single Arbitrum blocks. I mean, it is possible today, but when we think about the sort of level of decentralization that the Arbitrum community wants, we need this to be possible on an ordinary user laptop at reasonable cost in reasonable time. That will likely soon be possible. Now, imagine a world where that's the case, and also a world where well-resourced parties can ZK prove the whole chain at full speed, right? So you can prove a single block on your home laptop in, let's say, 10 minutes. But somebody who invests in some kind of special hardware or something highly parallel is able to ZK prove the progress of the whole chain at full speed. By the way, and do this for the more performant chains we're talking about and taking into account the Moore's law growth in node performance over time. The gas limit goes up and up. ZK is always trying to catch up. But imagine a world where you can ZK prove one block in 10 minutes and somebody who has a rack of equipment can ZK prove the whole chain in real time. Well, then you can have a best of both worlds protocol. That is, you can allow ZK proving for fast withdrawals. You can say, if somebody ZK proves the progress of the chain, great, the chain will accept that right away. You get instant confirmation to L1, or really confirmation at the speed of L1 finality. You get fast withdrawals to L1 at the speed of L1 finality. But you also want to allow optimistic proving, because that means that a home user who doesn't have a rack of equipment, doesn't have a huge budget, will be in a position to make an optimistic assertion, to engage in an optimistic fraud proof. If all of the ZK provers go away or turn malicious, you still, at home with your laptop, can force the chain to make correct progress. This, I think, is the future of proving on Arbitrum, and I think it's closer than a lot of people think. There's really active research to make this possible. It's around building out an infrastructure and software for ZK proving Arbitrum blocks and Arbitrum assertions. This, I think, is going to happen. And this hybrid protocol is, I think, the future. It's better than a fully ZK chain Because with the fully ZK chain, where you need to have that rack of hardware in order to really even be a participant in the proving protocol, you don't get the level of decentralization that Arbitrum has and that the community expects. So this also is something that will be available to the DAO, will be available to Orbit chains as we move forward. Finally, I want to talk about one more thing, and that is the rise of coprocessors and cross-chain interoperability. Can we make cross-chain interactions between different chains, and not just a cluster of chains, some sort of, I don't know, mega chain, where you have a bunch of centrally located, centrally governed, completely uniform shards that are communicating, but instead, a world where it's your chain, your rules, and fast interoperation between your chain and other people's chains with their rules. We think we can do this. The sweet spot, we think, in providing this will provide asynchronous interaction with a 1 or 2 second delay. That is, think of the way that different services on the internet interact with each other, right? No service ever stops and waits for another, but you have very fast messaging between them, and people can use APIs to tie these together and provide a sort of interoperable service. And I think we're going to see that coming to the Arbitrum ecosystem as well. So what's the best? I'm confident that this can be done. What's the best way to do that? Well, there are trade-offs to explore. Our Offchain Labs research team is exploring them. I know others in the community are exploring them. And I'm eager to see more and more development, ideas, and experimentation along these lines. This also, I think, is the future of the Arbitrum stack. If I have one takeaway from what I'm talking about today, it's that innovation in Arbitrum is accelerating. You can see this with, frankly, a kind of pileup of incredible upgrades in the DAO process. Bold, stylus, time boost, all ready to go. More things will come behind that. There's incredible innovation happening. It is accelerating as the community grows, as the Arbitrum research community grows. Innovation on Arbitrum is accelerating, will continue to accelerate. But of course, as innovation accelerates, I need to remind you it's your chain and your rules. Whether you are a DAO member, whether you're running an Orbit chain, you're the ones who are controlling this. You're the ones who will decide what goes on chain. So as an Arbitrum community researcher, I want to hear from you about what's important to you and what it is that you want to do. Because this is a community effort, and although I'm happy and proud to stand up here and talk about research in the Arbitrum community, research in the Arbitrum community will be driven by the community, and that's as it should be. Or, as a man once said, let's build Arbitrum together. Thanks.